concept on data and data classification. So data classification simply means organizing data in a different format than the original format. So here we have a map of the Hispanic population in the United States from the year 2000. And the type of data classification we have here is called natural breaks. We have 5 classes in the legend, and the light colored part of the legend means there is a percentage of Hispanic population compared to the darker colored side of the legend. We have higher population of the Hispanics population. And another classification, data classification, is the quantile. And again, we have 5 classes here, but we could see that our map for the Hispanic population shows more states with a higher Hispanic population compared to the natural breaks data classification. Our next data classification is the equal interval, and here with equal interval we still have 5 classes, but we could see how the data is visually showing here as not as prevalent of the Hispanic population like we see in these other data classification types. So why should we classify our data? Well, we need to classify our data to organize it and simplify it, and it's important to generalize our data into meaningful categories, and this also enhances communication. Before classifying data, what should we consider? Well, you should consider the distribution of the data values on a number line or histogram. So here is an example of a number line. This is a number line for percent urbanization, so the percentage of urbanization for these counties. And a number line is a simple line with values like we see here. And again, you could arrange it in ascending order. So we just reviewed the methods for classifying data, such as equal interval, quantile, and natural breaks. So for the equal interval classification, this is based on a range of data values. So again, equal means the width categories are based on the maximum and minimum values. The advantages of the equal interval classification that it's easy to calculate and to interpret, and there are no missing values in the legend. The disadvantages are that there's extreme variation in the number of units per category, and some categories might not have any units, and class limits do not consider how data are distributed. So to calculate equal interval, you must determine the range. So you must determine the highest value of your data and the lowest value. So in this example, our highest value is 42.1 and our lowest value is 0.6. When you subtract that, it's 41.5. You divide the range by the number of desired categories. So in this example, we want 5 classes. So you divide 41.5 by 5 and you get 8.3. You add 8.3 to the minimum value to determine the first class. So our minimum value is 0.6, so we're going to add our 8.3 with 0.6 and we get 8.9. So our first class is 0.6 minus 8.9. And then for the second and remaining classes, you're going to continue to add the 8.3 to the highest value of the last class. So our highest value of our first class is 8.9, So you're going to add 8.9 with 8.3, and then that will give us our next class, our second class. And for the quantile classification, this is based on the values divided evenly into the classes. So advantages are that it's equal number of values per category. The disadvantages is that the class widths are not equal. So when you have 4 classes, it's called quartiles, and when you have 5 classes, it's called quintiles. So how do you calculate quantiles? So you divide the total number of observations by the total number of classes. So in this case, we're looking at 48 states. We're excluding Hawaii and Alaska, and we want 5 classes. So 48 divided by 5 equals 9.6. And again, if you're looking at 50 states, you would divide it by 5, our number of classes, and we'll get 10. So this is a rough estimate of the number of observations for each class. So the rule is if you have 2 observations that have the same value, always put them in the same class. So in this example that we see here, this is the percent of population living on active farms with the county names on the x-axis, and then the percentage. So if we're looking at counties, we see that the number of counties in each class, so these are the abbreviations of the counties, it's the same. So we could see there are 4 counties in each class, 1, 2, 3, 4, and so on. So again, quantile, we're looking at the equal number of counties, whereas the range is different. So here the range for class 1 is 1 to 3, and then for class 2 it's 3 to 10. So that's important to review. When we compare the percentage of population living on active farms with the equal interval classification, we could see that with the equal interval classification, the counties, it's not equal compared to the quantile. Instead, we could see for equal intervals, the range is the same between these counties. So in equal intervals, between the range is all the same. We could see the missing county here for class 3. In the equal interval categories, there is no county with a population from 27 to 39. So if you do this type of classification, you'll have a 0, you won't have a county here. Whereas if you do this classification, the quantile, you will have a classification for class 3. And this is how the map looks based on the percentage living on active farms. So this is the equal interval classification, and we could see the darker colored shade shows us a higher percentage of active farms compared to the lighter shade. And so we could see there's 2 counties with active farms, whereas if we did the quantile classification method, we could see there is more counties that have active farms. So again, we're looking at the same data set, it's just visualized differently depending on the classification method you choose. The next one is the natural breaks classification. Again, we're looking at, this is the natural breaks in data by using a histogram or number line. The advantages of this is that its similar groups are kept together. The disadvantages are that many values may be clustered into one category and class limits are subjective. So like we could see here, we see a natural break here in this histogram. On the x-axis, it's persons by square mile, and on the y-axis, we see the number of counties. So this histogram is based on the Oregon population density by county. So when using the natural breaks, it's considering these breaks right here, and another natural break. So when we look at these three maps using different classification methods that we just reviewed, we could see the quantile looks different from the equal interval map. So again, here for example, showing Florida, higher Hispanic population, showing the quantile method compared to the equal interval. So in equal interval, the Hispanic population looks different. So even though it's the same data set, it appears different because of the different classification method. So which classification method should you choose? Well, you want to maximize the between class differences and minimize the within class differences. Quantile and equal interval are arbitrary. A better way is to input the class breaks manually after careful study of the data. Quantile is better when data is small and clumped together and you need to tease out the differences. Whereas equal interval, it usually results in flat, bland maps, which are not good for social data. So we could see here for the equal interval, it is not good for data distribution. It looks bland and flat when we're looking at the Hispanic population. So if you're using equal interval, it's good. It's better for environmental data such as temperature. And natural breaks are better for some social data like population data, like we see here in this map. So visualizing your numerical data, for optimal size for classes, it's best to have at least 3 classes or more to show your distribution of data. And to see the distribution of your data, it's best to draw a number line and plot each observation along the line. And to classify manually, arrange your data in order from smallest value to largest and decide the type of classification, as well as divide your values into classes. And lastly, I do want to talk about map elements. So what should be included in your map is based on a scale, title, author, north arrow, date of preparation, as well as the legend. So in your lab course, you will be looking at these different types of map elements to present your data the best visual way possible for your audience. And thank you for watching.